So my name is Álvaro. I'm from Brazil. This is my first Django Con, actually. Thank you. And I'm known as Turicas on the internet, so you will find like GitHub, Twitter, etc. That's my email. And I'm here to talk to you about Postgres. So I started with free software in 2004 and programming Python 2005. So in 2008, I think, I started using Django for some projects. And Postgres was like the natural choice. It's like a free software database. It's flexible. It's robust for production environments. And the thing is, usually people don't use Postgres the most it can like provide in terms of performance. I'm going to talk just a little contextualization here. I run this little company in Brazil called Pythonic Café. Here are my contact details. And there we work with open data, like open Brazilian data. And we develop software to clean and analyze this data. So for example, we could take the deforestation database from the federal government and then clean everything, try to figure out who is the responsible for each kind of deforestation, and then cross this data with other open public databases. So for example, we have elections this year, and I can find which candidates are responsible for deforestation in the Amazon, for example. If I cross this database with another database, we have like the company registry. We have all the partners for all the companies in the country, registered in the country. So we can also find other kind of commercial interests of the politicians and the people who deforest. So that's what we do, and we use Postgres a lot for all our projects. I will talk about our setup and data set. So I prepare a little Django project for this talk. You can access on GitHub after the talk. And you can actually download the whole data set I'm going to use here. So first, I'm going to give like general advice about performance. I'm not going into like deeper details on this general advice because this is like more common sense, I think. Then I'm going into more details on how data modeling can affect database performance. This is something that people usually don't think about. Then I'm going to talk a little bit about full text search in Postgres, the best way to ingest data. And you can take a picture of this slide. These are the two links probably you're going to need. So the first one is the link to the slides, and the second one is to the application I told you. So let's start. I'm using Docker Compose. So we are running just two little services, web, the Django container, and DB, which is the Postgres container. I'm using Python 3.11, Django 4.2, PsychoPG 2.99, Postgres 16. I'm using this library that I created called rows. It will make it easier to ingest data on Postgres. And I started everything from this template we created. It's like a cookie cutter Django template for putting everything in containers and make it easier to start new projects. So the data set we are going to use is from this project called Brazil.io, which I founded in 2018. We have lots of data sets in there, and the most fundamental one is this with the company registry. So we have all the companies in the country, it's like 69 million companies registered. all partners and all information about public information we can access about these companies. This is a very fundamental data set. We can like join with others to find things. I work together with investigative journalists, and we find a lot of useful information from this data set. So talking about the table we are going to create. So there's only one table, the company. I'm not going to put partners and other tables here because it's a short time to talk about too much data. And I also already cleaned the data. So we are going to work like just from the import, modeling in Django, importing data, and so on. Sorry. So we have 43 columns, 69 plus million rows. And the compressed file, CSV, is almost 7 gigabytes, and uncompressed, it's 17 gigabytes. So let's start with the general advice. First thing, if you are suffering from performance issues, you should know the problem. I mean, you must investigate what's going on, right? Before making any change, know how to use like the explain and PSQL client, and try to investigate what's happening, right? Then you should write better queries. So you should not load every data every time. Sometimes you just need some columns of the table. So the Postgres server don't need to fetch all the columns and transfer through the network to Django. You can use defer and values to do this. You can also avoid 1 plus n queries using select related. And you can, of course, create indexes. There are some links here you can use to help in this process. But as I said, I'm not going into the details here because this is like general advice. Okay. One very important thing is to use the same software. So if you have like Postgres 12 in your development environment and Postgres 13, 14, etc. in production, bad things can happen. So try to use the same version, and please do not never use SQLite for testing. Some people use it because SQLite is faster, run the test faster, and it's not a good thing to do. I advise you to upgrade to the latest version. Postgres has like many improvements. Every year there's a new version, and you can like save some space and also get queries run faster just upgrading. And it's very important also to know your infrastructure. Usually programmers don't know too much about infrastructure, but it's important to understand what's going on. So for example, check the configuration parameters. You could use like the full text search instead of other solutions for searching, and you will end up with like less data transfer between instances. You could avoid using Celery and Redis, for example, in using procrastinate to create a task using Postgres. So there are lots of things you could do to simplify your infrastructure and data flow, but I'm not going into the detail of this. I just put some links so you can search afterwards. But just as an example, I'd like to show you the difference of just upgrading Postgres. So if I had this table with company data imported on a Postgres 12 instance, I'd get this 13 gigabytes of table size and 5 gigabytes of index size. If I just upgrade the version, same data, same columns, everything, I will save 5%. just upgrading the version, right? So if you can't upgrade because your cloud provider doesn't provide the support for the new version, consider changing your provider, because you can save a lot of money just running the new version, and you also will have some performance gains just upgrading. So let's talk about the app. As I said, it's just one table, but I've implemented 5 different models. So the models will have like the same data, but there are just little differences in this data modeling. So I can show you the differences for which model, and you can check the performance gains between them. There's just one view, so the user can search for rows. I've created a very simple, I'm not a front-end developer at all, a very simple form that the user can like type some query to search for a company name, and also select the state. So I'd like to search a company from São Paulo, for example. I can select the state and put a name, and I can search. And there's also one management command to import the data. I'm not going like to show every line of code here. You can check afterwards on GitHub, but that's the main thing, you know. So the first implementation is the laziest one. It's like just copy the column names, use some simple types, and do not create indexes, etc. So also uses Django primary key. I've used just these types, no indexes, and that's the space used. So I got 14 gigabytes of table space, and there's a very important distinction here. Some people do not create indexes, and some people create a lot of indexes. Sometimes your indexes are not going to be used because Postgres decides it's better to not use a specific index. And you can waste a lot of space just creating indexes that won't be used. And Postgres has statistics about it. You can check which indexes are not being used and delete them. I have some very special cases where the index size is bigger than the table size, but it should not be like the default, you know. The default scenario, you should have like little indices, and comparing to table size, it should not be like very, very proportionally very big. So let's check the code. Oops, sorry. So this is the first one. The table names and column names are all in Portuguese, but it doesn't matter for you. I mean, it's just the field types and the parameters we are using here. So I didn't add a primary key, as you can see. So Django is creating a primary key for me. The fact is that in this data set, I have this UID field, which is a primary key. So I could be using this as a primary key and avoid Django creating another column and another index, etc. So this is the first flaw of this, this implementation. And I see a lot of this during code reviews and when I see like legacy code. So the first thing I'd like to discuss with you is the size of the ID. It seems to be something like simple. I have like all the tables have an ID, but do you really need a sequential ID? For example, in this case, I do not need, because every company has a number, and I can actually generate an UID hash of this using this number, and then I can have a primary key, right? So in this case, I don't need it. And another thing is that before Django 3.2, the ID of each record used 4 bytes. That's the auto field, right? So for every 1 million rows, it will use 4 megabytes plus the index size of this column, right? But after Django 3.2, it now uses 8 bytes. And for every 100 million rows, you are going to use almost half a gigabyte more just storing like 000 bits. And usually you don't need this. So you can change on the project settings, the default autofilled variable, or inside the app configuration, you can also change this field. Let me show an example. So I have here, my fancy interface. Here I can put, for example, padaria, which is bakery in Portuguese. I can select a state and then click search. I've also created this field called model, in which I can select from which table it's going to execute the query against. So for this first model, I'm going to click search, and it returned like in 0.033 seconds. But this is actually not the correct result, because I just truncated the table just seconds before starting this talk, so I didn't load the data here, so we cannot like count this value as the correct value. We will check the time afterwards using the other models. Okay, so regarding IDs, if you can use like or generate the IDs offline, for example, if you have some kind of methodology or business rule, it's preferred to have this instead of letting Django create this information, because usually the data comes with a primary key where like you collect the data. Like, for example, in this case, every company has a unique ID number, and every person has a unique, for example, SSN, and so on. And I've also developed a methodology to creating these UIDs in a consistent manner and also offline. So you don't need like to to look into like a central database or API to check every ID, to know every ID you need for your objects. I'm not going to talk about this today, but you can check urlid.org to know more. Who knew about this already, about the integer, big integer autofilled? Okay. Let's go to the second implementation. This one is more compact. So it doesn't use Django's primary keys, because there's a primary key column already. And it also uses small integer field when possible. So before creating this model version, I've executed like select min field name, max field name from table to check all the minimum and maximum values for each column. And then if they are in the range of a small integer field, I can replace the integer field with the small integer field. And the saving in space will be 2 bytes for plus times the number of int columns times the number of rows. So we can save a lot of space in here just changing from integer to small integer. For example, for each 100 million rows, you're going to save, like if you have 5 columns, change it 1 gigabyte for every 1 million rows. And you probably don't need to go until this 9 quintillion, I don't know how to pronounce ID number, right? I think from minus 2 billion to plus 2 billion is fair enough for almost all the tables we have. So With this little change, I've saved almost 3% of space for this case. Obviously, it depends on how many columns you have, how many rows. But in this case, I've saved almost 3%. And the thing is, now I also have a new feature, let's say. On the first implementation, I only had the ID indexed, the ID created by Django indexed, right? So if I would like to search for a company ID using like the UID, there were no indexes for this kind of search, right? But now, since I've set the primary key to that UID field, I have an index on this column, and I can also look up my companies faster, since it's like a real ID. It's not something created automatically and sequentially. So let's show you the differences. It's not that much, but you can see the primary key here, right? And then you can see also some small integer fields. In this case, we have actually more than 5, so the saving space would be like more than 1 gigabyte per 100 million rows. And I can choose here the second implementation and run the search. So as I said, don't count on the first one because the table was almost empty. So this is like the real time to look this and to execute this query on my machine, right? So here I'm executing like a where, so where state equals to AC, and then the legal name and brand name like padaria, right? And it's like almost 10 seconds to return. I could show you here in the logs. The query is like this. So where? This is just a little filter I put like to return only active companies. UF is the state in Portuguese. And razão social is the legal name, and nome fantasia is the brand name. So it's like a like operation, right? Oops. Okay, so let's go to the third implementation. Now, what I've changed is the order of the columns, just the order of the columns. So if you put first on the model declaration fixed size columns from the biggest to the smallest, and then variable size columns, Postgres will use more efficiently the space to store every row. I'm not going into the details about it. There's a link in here you can read more about. But just changing the column order, I've saved 3% of space. Same data, same columns, just the order. So let's see the code. I've added some comments so you can see how many bytes each type of column uses. So for example, UID uses 16 bytes, right? Date field and integer field, 4 bytes. Small integer, 2 bytes. Boolean, 1 byte. And then the variable length field, like decimal, text, etc. So if Postgres creates the table this way, when it reaches a row, it can calculate like easily with just multiplying by the column size, the field type size, and you can reach any of these fixed size fields here without needing to like worry or look up how many bytes that information in that row will be using, right? Because it's fixed. So it's not only better for saving space, but it's also faster for executing queries. So just changing it will you have your queries running faster, right? Let me see if I changed anything else. No, that's it. So all the text and decimal fields are here. Okay. So I could like change here. Obviously, could be like some fluctuation here in the time, the query execution, because for each table, Postgres could have more or different statistics regarding when I've inserted data. But more or less, the time would be like the same in this case, but it will like save space, and for some types of queries, it will run faster. In this case, since I'm using a text field, Postgres will need to reach that variable length field, right? So in this case, this query won't run just faster because of it. Oops. Okay, so let's go back to the slides. Who knew about this already? Nobody. Okay. So a little tip here. Doing all those steps, it takes a lot of time. So if possible, try to automate those things. I've implemented a command on the rows command line called schema, and it can like detect for you which type of each column. If you have, for example, data in a CSV or XLS file, I mean, doesn't matter. It can look the data, try to figure out the data types, and then you can have the output using a Django model declaration. Or you can use like format equals SQL or whatever. So try to, I'm not like advertising to use my library here, but try to use something to automate the process. It will be easier than like to every time you need to create a new model thinking about all those stuff, you know. What I usually do is import all the data as text, like every column will be like text, and then I can run specific queries on that table to detect the fields. Then I can create the final version with all the fields typed correctly, etc. So the fourth implementation would be to improve the performance using full text search. I'm skipping a natural step here that would be create an index for that those like queries run faster, okay? You could do this, but I'm not going to do this because I have only 45 minutes. So I'm just jumping directly to full text search. What I've done here is to add a new field to the model called search data. It's a search vector field. So it's going to take the text I want to index, create a vector, and store on this column, right? But I've also created an index for this column. So the column is a vector that represents the words, for example, on that row. So if it's like that, it will be easier for Postgres to like calculate, pre-calculate this vector, and then the query could run faster. But adding an index would be much faster. So here we have like 3 scenarios. One is the last implementation, right? No search vector field. And I could use full text search on that scenario using some Postgres functions to create this search vector, for example, from a column, one or more text columns I have, right? So I can transform the strings in these columns into this search vector and then run a query against this vector. So Postgres would be like going through all the rows on the table, calculate the vector, and then check if the vector matches my query, right? If I add this field, I will pre-calculate the vector. So Postgres would also run through all the rows, but the vector will be already calculated, so it can just run the query against. But if I add an index, Postgres would not need to go through all the rows. It can use the index to find out which vectors to check, and then it will be much faster. Another thing I've done here is to create a trigger. And a trigger is just a little way for the database to perform an automatic task. So for example, after inserting or updating a row, update automatically this field, or update, for example, my search vector based on that new data I put on that column, for example. It's much faster than doing inside your application. So Postgres, people there are like working from dozens of years optimizing every possible thing inside the database, and it would be much faster to use a trigger, for example, inside the database than doing filling like this search data field inside your Python or your Django project. Some people avoid creating triggers, but I think this is a very good feature from databases. And if you don't put like too much logic in there, like business logic, it will save a lot of time, and all the things could like run smoothly. So in this case, the table size is bigger than the last implementation, but I have a new feature here, right? I have the full text search. So I'm not comparing the values just because, I mean, it's something new we've added. So in total, we have now 21 gigabytes. And with this implementation, I can search here and have the query executed like in 150 milliseconds, right? Same data, same results. I mean, the ranking here could be different because the full text search uses a different ranking algorithm than the other one, but the result is consistent, right? Okay. And there's also another possible implementation, which is not creating that search vector field, but also pre-calculating the vector. So in the last implementation, I said we could do like 3 ways, right? Pre-calculating, calculating the vector during search execution, and also matching the vectors for executing the search. Then, second method, creating this field without an index. And the third, creating the field and also the index, right? The other option here is to create an index of the search vector without having to create the search vector. It could be like a little complex in the beginning, but you don't need to use like index for just the plain value of a column, right? You can calculate an expression based on the column values and then create an index for that expression. If Postgres detects your query uses that expression, it can use the index. So if, for example, I have a query like select asterisk from my table where column A plus column B equals to 10, something like that. I could index column A plus column B, right? And this will be pre-calculated and stored in the index, not in another column. So that's what I've done here. No trigger, no more search data field. I've created this compound gene index that's a result of the expression to calculate the vector field. the search vector. And then I could save 20% of the space comparing to the fourth implementation. So I'm going a little deeper here in the code to show you these differences. This is the fourth implementation. I have here the new field called search data, right? This is a search vector field. And it's, by default, it's null, and it will be filled by the trigger, right? I've also created here this index, this gin index for this new field. And the migration to create the trigger is pretty simple, actually. So I give a name for the trigger, and I say that before any insert or update on this table, the fourth company table, Postgres will, for each row, execute this procedure. It's just calling a function, right? This function already exists in Postgres, and it's just updates the search vector. So I pass here the name of the field, which has the search vector, the language, here's Portuguese, and the fields I want it to like concatenate and insert on the search vector. That's it. But on the last version, I don't have the search data here anymore. And I have the search vector inside the index definition, right? So it's going to calculate this and store it directly in the index. I don't need the trigger. It's going to do it like automatically. And of course, you could use other compound indexes to make this kind of queries execute faster. Okay, so let's check. If I click here and run, it's also going to run. Oops. Okay, a little bit more. I don't know why, but less than 1 second. Okay. Let's go on. So there are also a lot of other Postgres-specific features. I'm going just to list it here because I don't have time for it, and I'm also want to finish with the ingestion process. So you could search for array field, JSON field, and other integer range field, and other things Postgres have that it helps a lot, and it could save space and also make queries run faster. Also, Postgres has specific kind of indexes you could use. So depending on the type of query you want to execute, probably you want to use B3, which is the default kind of index. So it's also a good idea to read more about all the types and then select the correct index for your use case. Full text search, I said already. And there's also more in the Django documentation. Just to finish this part, I'd like to show you this query set I've created. Postgres, I mean, it has the full text search, but you need like to build the infrastructure, right? So it's not that easy to start using it because you need to configure the search vector and all this kind of stuff. And here is just a sample query set you could use to like not only executing the search on the language you want, but also ranking the results, ordering the ranking, etc. So you can just take this code from my GitHub and use it on your implementation if needed. Okay, so let's talk about importing data. I've created a management command to import data, and this management command has actually three types of models of working. The first one is like for each every CSV row, it's going to call model.objects.create, right? So one at a time. I started running this, and I've like spent a little time and then stopped the process because it would take like more than 1 day to finish. And here there's a little detail I'd like to talk to you. I'm using the compressed file, right? So the I/O on the disk is less than if like the file would be uncompressed. And even with this, I mean, there's the overhead of the compression, but even trying to reduce the I/O, it's not going to perform very good. The second thing is to use bulk create. It's faster, but it will take like 2.5 hours. I can't wait for this time. The third method is to use Postgres copy command. So there are lots of ways to invoke this command, right? I've implemented on this rows library this function called pgimport, which calls the copy command, but you could use any other implementation. This is just a handy function to, it like creates all the copy SQL string for you. It detects like the field names and the dialect, the CSV dialect, and everything else. So you can just pass the CSV file name and the table name, the database URL, and it works. So it uses PSQL and then executes the copy. And I could execute in 8 minutes, 20 seconds, which is more or less 123,000 rows per second versus less than 1,000 per second, the first method. Okay, so this library actually has pgimport and export, so you could also use the command line interface to export, for example, the result of a query to a compressed CSV file. And this is just an example. So I think my time is almost over, but maybe I can take one question. I don't know. Thank you.
Looking right now and see how you showed all the different models and how it was improving, it looks pretty easy, but looks like a tough journey to get to know how to improve each version that you had. How did you know that there was more to come? And how was your journey to find each of these improvements? How long does it take? What was your experience?
Nice question. Well, I was not satisfied with the results, basically. So the queries would like take too long to run, or I would need to wait too long for the data to be imported. And at every process, I try to figure out how I can do it faster, you know? And it takes time. It was not like reading just one thing, you know? It's like lots of iterations over it. But I think Postgres, unfortunately, you need to dig a little bit to use it like maximum performance. But that's it. It's time and trying error.
With the fields ordering thing, I suppose that if I already have a project with a bunch of models, the tables are already created. If I reorder my fields, it probably won't make any difference, right?
Yeah.
Any advices on like recreating all the tables, basically? That's...
I've started creating a little Python script to read a table, do the correct alignment, and then create the SQL code to like start a transaction to create a new table with all the aligned data, move everything, and then overwrite the first table. So maybe I can release on GitHub, and that's it, I think. I don't know if Postgres has something like automatically to do this? I think no.
Okay, thank you so much.
Thank you very much.
Once again.